into x plus 2 in the denominator. Okay, so in the denominator you have linear factors, the degree of numerator is less than degree of denominator, therefore it is a proper rational function. First thing, okay. Second thing, denominator has been factorized, that's also okay. So now we'll convert it into partial fractions and then we'll integrate, yes. So let's try to write this expression x upon x minus 1 square x plus 2 as partial fractions. And how do you divide this into partial fractions? Okay, this x plus 2 is single, so it will not be a worry. This x minus 1 is a square, so we'll have to write a upon x minus 1 plus b over x minus 1 square. Okay, this is what we'll write it as. There's no need of bx plus c over here. What else? Plus c upon x plus 2. That's the form in which this will convert. Right, that's the form. This is something which you should remember first, that if you have a linear factor and it's a square, you write a upon x minus 1, b upon that linear factor squared, right? That's what you do. And after this, finding values of c will not be difficult. Finding value of b will also not be difficult. What you can do is you can simply multiply with x minus 1 square. What are we doing? We are multiplying with x minus 1 square, right? This will have x minus 1 remaining, this will have x minus 1 square, and x minus 1 square goes from here, and we'll put x equal to 1 to get the values of b, which is 1 upon 3. So b, using our shortcut ideas which you have discussed before, b will be 1 by 3. C can be substituted by multiplying with x plus 2 throughout, and multiplying by x plus 2, then substituting x equal to minus 2, we will get minus 2 over, this is minus 2 minus 1, which is minus 3 square is 9. So c will be equal to minus 2 upon 9. Something which you can do directly, right, by using the shortcut ideas which you have discussed in the previous questions. But here, the other important thing which remains is a. So can you find a in using that approach? No, the answer lies in, okay, we can multiply with x minus 1, but there will be x minus 1 remaining over here, there will be another x minus 1 remaining over here. So will we be able to substitute x equal to 1 over there? No, you will have zeros in the denominator, which is not okay. Therefore, we could find b but not a, yes. So once again, the NCERT people love the longer approach, and we can follow that longer approach whenever we want. But here, another shorter approach for finding the value of a, what you could have done is simply maybe substitute the value of x as 0, yes. Since you already have b and c, you can get the value of a easily. This LHS will become 0. Oh, this is an identity in terms of x, so this is true for all values of x, so I can substitute anything. Therefore, I can substitute 0 as well, yes. That is another idea to get the value of a. Right. But the longer approach which says, okay, that numerator x will be equal to what? Here, you'll have to take the LCM of x minus 1 square, x plus 2. So a will have x minus 1 times x plus 2 over here, plus b will have x plus 2 only, plus c will have x minus 1 square. Please note this, yes, this is what you'll have. So there's x minus 1 missing over here, x plus 2 missing over here, that comes over here, there's x plus 2 missing, that comes over here, x minus 1 square comes over here. Right, that's the LCM. Now we can compare. Now what does comparison tell me? Comparison tells me, okay, compare the coefficients of x square, coefficient of x, and the constant term. So coefficient of x square is 0 on the left hand side, as you can see. Okay, there's no term of x square on the left hand side. What about the right hand side? There's x square over here, there's no x square over here, there's x square over here. So a x square plus c x square is what I have, right? Coefficient of x is 1 on the left hand side. What is the coefficient of x on the right hand side? This is 2x minus x. This is 1x into a. This is ax plus bx, and what do we have? Minus 2x, so minus 2cx. This is what you have, right? What about the constant term? The constant term is 0 over here. The constant term is minus 2a over here. The constant term is plus 2b over here, and the constant term is plus c over there, right? So you have 3 equations and 3 unknowns, and this particular equation only has a and c, right? So one of the things is we can substitute c in terms of a, and then maybe we can eliminate b as well, right? First we can eliminate c, then we can eliminate a. Or since this is already eliminated b, so we can eliminate b from these two, right? Which of these will be easy? Anyone for that matter, right? So what I'll do is I'll eliminate c from these 2 equations. These tell me, okay, c is minus a, so this becomes 2a plus a is 3a plus b, which is equal to 1. What else? Here I'll have minus a, so this becomes minus 3a plus 2b, which is equal to 0. Adding these two will give me 3b equal to 1, or b will be equal to 1 by 3. And a can also be found from here. what you'll get is 1 minus 1 by 3 is 2 by 3, and by 3 a will be equal to 2 by 9. And then using this, c will be equal to minus a, that is c is equal to minus 2 by 9. This is what you get. Oh, c is equal to minus 2 by 9, we found that. B is equal to 1 by 3, we already found that using a shortcut approach. Yes, yes, right. So this is the complete partial fractions. Okay, this is the step of partial fractions. Integral I, which was x upon x minus 1 square x plus 2 dx will become equal to integral of, this is a upon x minus 1, a is 2 by 9 upon x minus 1, b which is 1 by 3 upon x minus 1 square, and c which is minus 2 by 9 upon x plus 2 dx. This is what we have. Is that okay? Yes. So this is 2 by 9 log modulus x minus 1 plus 1 by 3. Okay, this is dx. Okay, we have to divide with the coefficient of x. The coefficient of x is 1, that's not an issue. Here you have 1 upon x square kind of thing, right? So the integral will be equal to x power minus 1 upon minus 1, which is 1 upon x with a minus. This is minus 1 upon x, right? So what you'll get is minus 1 upon x minus 1 as the integral of this. This is minus 2 by 9. Integral of this will be log of modulus x plus 2 plus a constant term. That's my final answer. Okay, this can be written as minus 1 by 3 x minus 1, and let me write that step as well. This is 2 by 9 log modulus x minus 1 minus 1 by 3 times x minus 1 in the denominator, right? And minus 2 by 9 log modulus x plus 2 plus constant term. That's the required answer for this particular question, as you can see over here.